So I guess we'll pick up where we were yesterday. So we were working on our um, Google Generative AI client. I guess we can pick up there. Off stream, I did do a little bit of work on setting up the generated file to work a little bit better. And I also cleaned up the stream request method that we worked on yesterday to avoid unwrapping the stream multiple times. So now we actually have a pretty nice setup for doing this, and we can show off by so in our Scratchpad file, we have so we were testing yesterday whether redaction was working with the client layer. So right now I've got the model specified, but it's incorrect. So if we source the environment and then we do a npm26 Google API is key to exist in the process context. So we should be able to run this, get an error, and the API key is redacted, which is what we want. And if we don't redact, if we have a correct model and we run this, we should see all of our generate content responses, which is what we want. So this is kind of where we left off yesterday. And so this is a good start, this stream request method, which again is going to return a stream of these generate content responses, but the effect AI APIs are kind of a unified model over the top of all the different providers. It's similar to how the AI SDK from Vercel works. So while we have this stream request method and it's useful, whatever, what we also want to do is we want to take all of this stream of responses and unify it into the unified AI response data type that we have. So instead of getting a stream of generate content responses, we get a stream of AI responses. So we can actually take a look at how we did that for the Bedrock provider that we have in a PR over here. So if we take a look at the client, you'll see in here we've got this stream method which takes in the request, and under the hood it does call stream requests, but then we map the response basically into the shape that we want. So we're gonna have to figure out basically how to do all this logic for the Google one, but we can start off with our signature. Options, typos, generate. We're gonna want to use suspend because we're probably gonna have a couple of mutable variables that we're gonna be dealing with. We can rename these to request instead of option email. Same thing up here. Awesome. Okay. This is C8 generated. So the goal here is basically to have something that looks like this. Read only stream, and it's going to look like this. And it's going to return a stream of AI responses. Not entire. I think AI error is what we're going to want here. And I think that's it. We'll start with that. So let's import. So we can start off by literally just returning stream request, and we know we're going to have to pipe this to something, or I'll just use the same structure that I've got currently for the Bedrock one, which, and actually we can also take a look at, we can take a look at the OpenAI one if we need more inspiration, but the Bedrock one should, let me open it up here so I can reference it. Okay. So at the very end here, we're going to be basically collecting parts of an AI response as we go through this stream. And eventually, so this is the way the API kind of looks now, is we have this mutable array of AI response.parts. And we basically take this response and we massage it into a part. And then at the end, we do something like return. What do we do here? We do, part dot length equals 0. And if it is, we return option dot none. Otherwise, we return the option some new, or sorry, AI response dot make parts. And we have, we always disable. So with the schema libraries, they'll automatically do validation for you based on the data you pass in to the constructor. But since we know that the data we're passing in is going to be the right type and shape, we can do a small performance enhancement and just always disable validation. Because these constructors, like I said, have options, and so you can actually turn off validation. Let's fix that, and let's also import option. And then I'll explain what's going on. So like I said, in here, we're basically going to transform the response into AI response.part, potentially multiple. And we have everything in a suspend because there's going to be some mutable variables up here, most likely, that we'll use to track things like what the finish reason was, what usage we used for this particular request, etc. Let's see. All right. And then filter map is a method on stream. It's like filtering. It's like normal filtering. The filter map constructor expects you to return an option. So the none case would filter out that value from the stream. You would not see that value. And then the sum case allows you to return a value that does not get filtered out. And The reason it's called filter map is because you can return a different value. It doesn't have to be the same. So when you call option.sum, this can be like any transformation on the incoming value. All right. Think about this for a second. We need to learn about this response shape. So where can we go? You go to the docs and take a look at this. So maybe the first thing we can try to figure out is the like when we have a finished reason, maybe. Let's see. So inside this response, if we actually rerun our little script here, we're gonna get this like candidates array, which is just a bunch of like candidates, like text generation candidates. So what we can do is we can first try to extract the candidate, I guess. Candidate equals response.candidates 0. And I guess there are cases where candidates won't be defined. Maybe what we can do here is if predicate dot is not undefined candidate, or how do you do this in TypeScript? It's like a question mark dot. Yeah. So if we don't have a candidate, maybe we can just return an option dot none. Filter that out. But if we do have a candidate, go to this comment. Let's see what's in there. So candidate dot bunch of stuff. Just looking at the docs as we do this. So the finish reason is what I want to start. It's like an easy way to start. So we can do if is not undefined. So if we have a finish reason, how do we do this? And here, reasoning content. If we have a finish reason, we can parts.push a new AI response dot finish part. So the AI response, like I said, is just a container for a bunch of response parts. One of the different parts you can have is the finish part, which basically is indicating that the response is done. In here, we have a set, kind of like the AI SDK. We have a set number of reasons why the model like finished generating a response. So we need to map this onto our internal finish reasons. And I think for most of our packages, you have like an internal utilities. Is my Amazon Bedrock code here? No. Let's look at my Bedrock PR. So in my Bedrock PR, I do something similar to this. Record. Let's go back to the other file for a sec. What is the type of this? Candidate. Candidate. Class candidate finish reason. Here we go. So we want this. Here. Type generated dot type. And then we're gonna have our AI response dot finish reason. Whoops. Import type everything as a response. Oh, what my LSP just did. Import everything as generated from generated. And actually here we could probably just do this. Hey, the Stream APIs all return AI response to AI response. Hey, dummy. They all return AI response right now. Will you move them to AI response? Yes, that is the plan. I realized after the design of the most recent iteration of the APIs that it probably makes more sense for the Stream APIs to return parts, not to return the response directly. So, yeah, I'll probably have a separate PR where we convert all the providers and fix that all up. For now, they'll stay with AI responses, but it won't be too hard to migrate all the providers over. All right, so we're going to need to figure out how to do this in a reasonable way. So, block list. What else do we have in here? Let's go one by one. For block list, probably makes sense to be a content filter. Finish reason unspecified is probably going to be. What do I have in here? Other. Maybe we'll just do other, because unknown really means like we don't even know what the finish reason was. They have another as well, so we'll do other. Image safety probably will be a content filter. Language probably also content filter. Ow. What else? Malformed function call. If we have a tool call that's an error, then we should probably just do error. Max tokens. I think we have a length. Finish reasons. Prohibited content is definitely content filter. Recitations. like content filter, safety, content filter, SPI is definitely content filter, and stop is going to be stop. Okay, and now we can just expose like a really simple method like I do in the other providers, which is let's do resolve finish reason, which takes in a finish reason and return an AI result. The finish reason and I get accept. Cool. This bit, and now what we can do here, we can import everything as internal utilities from internal utilities. Cool. We're also going to need to track the usage information. So what do we do in our Bedrock provider? We do this is one of the mutable variables we'll have up here. And this will just come in here. It's just not happy. Why is this not happy? Oh, I gotta map that error. Okay, we'll take care of that in a minute. Actually, what do I do in the Bedrock client? Do I map the error? No. No, I don't. I wonder if I should. What does OpenAI do? What do we do here? No, we don't map it there either. All right, so then we'll actually just I'm not going to deal with AI errors here. And the last field on the finished parts is going to be like a provider metadata field. So we provide a mechanism on responses to extract provider specific metadata that we attach to responses that's not like fully typed in the AI response, but you can get it out fully typed as an optional value via. So if you have like a declare AI response, if you have an AI response, there's a method on here, get provider metadata, and every provider exports a tag that allows you to get optional typed metadata out from the response. So we'll set that up now because that's another mutable variable we're going to need to track as we accumulate the response. So let me just copy again what I did for the Bedrock provider. Here's provider metadata. Where are you? Oh, it's going to be the language model. Hmm. Oh, let's just set up the file. Google Generative AI Language Model. I'm just copying stuff that I did for the Bedrock provider at the moment. This is context. Abilities. And we'll put the provider metadata key in here to avoid a circular reference later. Where is my example? Here it is. Generative AI language model Google. As if we go back here. So basically, you can like do something like if you have a response, you can do response.get provider metadata Google generative AI language model dot provider metadata, and the type here would be wow, I cannot type today. Nope. Okay. The type here would be like option of provider metadata based on whatever we put into this service. So just like a way for us to return additional information to you without it being fully typed in the AI response. Otherwise, we'd have to like every time we had a provider, we'd have to update the types of AI response, which would not really be very like the whole point of the base AI package is to be totally provider agnostic. So instead, we attach it this way. So now what we can do is we can actually set up this metadata. Again, I'm just like copying boilerplate from the Bedrock version of this. Great. And so clean this up a tiny bit. So when our response finishes, we'll basically get this finish part that has all our metadata, our token usage. So it has like all this information in it, like the input tokens, output tokens, total tokens, all of this. And then if your provider supports caching, prompt caching, we try to track some of that information as well. So any information, how much of the prompt tokens were read from the cache and how much prompt tokens were actually written to a cache. So okay, what else do we need to handle? Look at the docs. Oh, that's interesting. We're gonna have to, in our finish reason resolver here, it's just reading that we can also get the stop finish reason if the finish reason was actually for tool calls. So we'll need to just leave it to do for ourselves when we start dealing with tool calls in here. Handle stop finish reason to tool. We'll come back to that when we start dealing with tool calls. The other piece of this that would be easy for us to do take a look at the first response, see if there's anything special in here. So there's in our AI response, we have like a metadata part. That is kind of like one of the first things that's supposed to get returned. So it's like, so a lot of models indicate to you like when a message is starting and when it's finishing, like when the full message is starting and finishing. So you can, as part of the stream, like understand if you're at the beginning or at the end of your response. This Google's API doesn't look like it does that. So we'll probably just have to have a flag so we don't keep emitting this metadata part every time we enter the filter map. So like, what is first response equals true? Okay. And this metadata part allows us to return, it has to take the model, which all of these responses look like they return. Of course, it's undefined. Maybe we can lie or just do something like this. What do we have in here? ID and timestamp. So we have an ID. Pretty nice API. One suggestion is maybe subclass context.tag here. Currently you use get metadata. Autocompletes here with context.tag. I wouldn't know what generic tag you should put here. Autocompletion maybe show response metadata tag or something, and export a. Maybe. The point is that method lives in the base package, which has no idea about the providers that are supported. We could maybe have like maybe instead of like making autocomplete more friendly, maybe we could have an example in the JS doc that shows like passing in a provider metadata tag, or maybe like improve the signature a bit to like say provider metadata tag or something. But the point is to have the method be like totally like agnostic of the provider you're using. But we could definitely include an example that would hopefully make it a little more clear. Why is this undefined? Well, whatever. I think this is fine. I think it seems like this is like a dumb little version of this, but it seems like the model version is generally always there. All right, let's see what else we need to think about here. So this is basically representative of like the beginning of a message and the end of a message. And now we need to handle everything in between. So like text content, image content, file content, tool calls. Probably easy to start with text. Let's see. Oh, and we also need to accumulate usage information. And the provider metadata. So we'll have to figure out like what's relevant to put in here. I wonder if we can just compute the metadata off of the for usage here. All right, we'll think about that in a minute. Let's maybe like get some other parts dealt with here. So here, I'll show you folks what I'm looking at. So for text generation, it looks like we're gonna have to go through the parts and grab all the text. But I think that Google also supports reasoning, so we need to figure out how they indicate that. multimodal inputs, streaming responses, multi-thread conversations, yada, yada, yada. Thinking. For every part of the candidate parts, if there's no text, don't deal with it. Okay, so they have a thought property that can exist, I guess. Let's see. I really want to see like what an example of a response with thinking looks like. I don't need to count tokens. I need to. Maybe if I just look at the API reference for a moment. Generating content, text generation. Oh, I want the API reference. Here we go. The request body and then generate content response, which has candidates, which has content, parts, a part is a data type containing media that is part of a multi-part content message. A part consists of data which has an associated data type. Part can only contain one of the accepted types in part.data. A part must have a fixed I and a MIME type and subtype of the media. Okay. It's such a weird. So I guess we're gonna have to. That's annoying. We're gonna do something similar to what we do with Bedrock. Not great. So the content can have multiple parts. Ordered parts that constitute a single message. Parts may have different MIME types. Let's take a look again at their example for the API docs, text generation. Examples are really garbage. All right. Well, let's do what we think, and we'll see. Or yeah. So we're gonna basically have to do the same exact thing we do with Bedrock. The thing is, if we have multiple parts that contain text, I wonder if we can just concatenate them. Because well, let's just do it the way we do it in Bedrock for now, and we'll go from there. So if text in part, then we do a parts.push new. Yeah, oh, we forgot our const disable validation up here, and down here. New AI response dot text part. Wait a minute. I'm saying I think yeah. If we have text in part and the part dot thought indicates that the part is thought and not part dot thought. And we're going to have to do the same thing. We also track reasoning content, or what we call reasoning content. Other people call thinking or thoughts, or I don't know, whatever. But we call them reasoning parts. So if the part is a thought, so if we have text and the part is not a thought, then it's a text part. If we have text and it is a thought, then it has to be a reasoning part. And the property is called reasoning text. And then we can do, I think I saw an opaque signature for the thought so it can be reused in subsequent requests. Yeah, I don't know. So some models, when they stream reasoning, the signatures come through as separate like pieces, or not, the signature comes through as one whole piece, but like the signature and the actual text that the signature is for come through separately in the stream. I'm not sure how that works here. Let's look at the spot signature. The heck? Okay. Once again, completely useless documentation. Perfect. Okay. Well, we'll test this out at some point, but I think this is good for now for text. We also need to handle images. If Gemini can do images, I don't know. Let's do tool calls next because I feel like that's going to be annoying. All right, let's see here. Function calling. Let's look at get weather. Maybe we'll use the rest API. Okay. This is the function declaration. There's the response. Response to function call 0. Model then returns a function call object in an open API compatible schema specifying how to call one or more of the declared functions in order to respond to the user's question. Of course, they don't return an ID. Like, why? Why? Really annoying. We're gonna have to do something like dirty. Mm, well, we're gonna need an ID. Maybe we can start with this and just see how this goes. So if in part, what's it called? Function call. Function call. The unique ID of the function call. If populated, the client to execute the function call. So okay. Does it? I mean, we're gonna have to test this, but most other providers will stream tool calls. Like if you're streaming, they'll stream the tool call as well, so it'll come back in like pieces. I don't think that's the case for Google. So I think we can just. What does it look like when the args come back? So they're just a JSON object. It's not a string. Yeah. So I think that means if I look at my Bedrock PR, mm, I think I can just do part and function. Well, args. Right. Input tool call ID dot make. Oh. So on our AI input type, which represents like you as the user providing input to the model, we have a branded tool call ID thing. So that is why we needed this constructor. But what else? Well, this actually might be a good place for us to say has tool calls, because we need to. So the finish reason in many other providers, when you have a tool call, tool calls. In many other like providers, when you have a tool call, the model's stop reason will indicate that it's because of tool calls. Like it will be like, it'll say something like tool calls or whatever, function call, whatever. It does not look like Google's generative AI actually supports that or does that. I think it returns a stop as the finish reason. I forget where I read that in here. I don't know. I don't know where I got that in here, but anyway, if we have tool calls, then the finish reason is stop. We probably want to map it to our own like proper finish reason. So something like if candidate dot finish equals, yeah, because you can see next token safety recitation language other block list. Yeah, there's nothing about function call in there except for if it's malformed. So if it's stop and we have tool calls, then we probably just want to make it tool calls. And we can leave a little comment here. Google generative AI will return a stop or a finish reason of stop when the model calls a tool instead of which, unlike other providers, which return a finish reason that indicates a tool is being called. I think this is enough for tool calls, I think. We have to see what these other types are. So this, when we look at part, so this inline data thing is one thing we might need to do for image or image or file information, but there's also this file data thing. So let's take a look here. Image generation. You can generate images using the Gemini. Generate content. It really is quite annoying that we don't get to see what the response looks like. So we have to like execute these ourselves. So if we have text, we show the text. If there's part.inline data, okay. Part.inline data, we grab the buffer. So image data, I guess, is binary. Or is it base 64? It's base 64, sorry. It's a base 64 string. So the data comes back as a base 64 encoded string, which we can convert, into a buffer. How do we know? How do we know if it's a video? Well, we don't even really support video yet very well in our response API. So let's see. If inline data in part, then well, that's showing that. It's fine for me. Whoa. Right, that was inline data, right? Yes. Yeah, and it's a string. Complete list of supported types. All right. Well, the goal is to end up with new AI response dot image dot types of parts do I support? Text, reasoning, tool call, metadata, finish. I guess I don't support images yet here, which is not ideal. I know I support them as input, I think. Yeah. We should probably support them in the response as well. All right. Adding image support to a response can be part of a separate PR. Let's get the basic client up and running. To do. Does video come back and speech come back and all of that come back in inline data? No. Set response modalities to include image, so the model can generate an image. Okay. The following code demonstrates how to generate an image based on a descriptive prompt. Okay, and that's when we get the inline data back. Down here. Okay, so this is probably going to be a whole separate, yeah. So right now we only have AI language model and AI embedding model. At some point, we're going to add AI image model and everything like that to the base package as well. And I think that's where we'd probably put things like image gen, or where we would have support for this. But I think we can support the inline data in I think we can support inline data in generate text and stuff. All right, let's just. So the only things I think we need, the only things I think we have left here are to support data usage information in the provider metadata. See if we can tackle usage. Token counting. Gemini and other generative AI models process input. Yeah, okay. Tokens can be single characters or whole words. Long words are broken into several tokens. A set of all tokens used by the models hold the vocabulary and the process is needed. For Gemini models, a token is equivalent to about 4 characters, 100 tokens, 60 to 80 English words when billing is enabled. If you call you can count tokens. Use the usage metadata attribute on the response object after calling generate content. Yeah, so prompt token is input tokens, candidate tokens is output tokens. So since they return usage metadata with every single part, we can either accumulate tokens as messages come in, or we can do it as part of the stop response. Let's see. Let me think about this. What do we do in the Bedrock PR? I think it's probably the easiest thing if we just do usage at the end here on like the stop message. So input tokens is going to be candidate dot usage, no, candidate dot, there we can, it's going to be response dot usage metadata dot prompt token count or 0. Output tokens is going to be candidate token count or 0. What else do we have here? Reason. Let's do total tokens. Total tokens. Response.usage metadata. This total token count or 0. Response.usage metadata. Thought token count. Number of tokens in the cached part of the prompt. Okay. I don't know if Google exposes information um about tokens that were written to the cache. Let's just take a quick peek inside cache. Token details. Uh, This could be useful on like the metadata. Like expose the they put like this modality stuff information. We could put that on like the response metadata. So with that, we don't actually need this. And provider metadata. So I know there's some interesting information that the candidate can expose. Like this could be interesting information. The grounding metadata, grounding attribution, citation metadata, URL context metadata. Like this could all be interesting. Let's do it. If predicate that is not undefined, and actually, I think we only do this. Um, well, let's just start with let's start with the arrays because they're going to be easier. Grounding attributions. We will do grounding metadata. There's some other stuff. Safety ratings. What else? Citation metadata and URL context metadata. I'm not sure when these things get generated. Let's just quickly take a look and see if the docs are useful for a moment. URL context metadata. Let's see. Using the URL context tool, you can provide Gemini with URLs as additional context for your prompt. The model can then retrieve content from the URLs and use that content to inform and shape its response. Tool is useful for tests. Okay. The model is responsible based on the content it retrieved from the URLs. If the model retrieved content from URLs, the response will include URL context metadata. Such a response might look something like the following. See, this is useful. Like when you actually show an example response, like this is useful. Let's start with this one. That. I think metadata.url. Let's go over here. Read only URL metadata. Type of generated.url metadata. context of the give this back. URL retrieval metadata, URL retrieval context. Whoa. Retrieved URLs. The URLs that were retrieved by the URL retrieval tool, I guess. URL context retrieval tool. And then this thing is don't quite understand. The model's response will be based on the content retrieved from the URLs. If the model retrieved content from URLs, the response will include a URL context metadata. Okay. Well. Okay. And what we should actually probably do, since this is per candidate, we should check if this is defined. Medicate release model. Undefined. else. Saved urls.concat and it stop. Okay. Safety ratings. Sure. So we can do the same logic. Where we do metadata.safety ratings equals what is undefined metadata dot safety ratings. Otherwise, okay. Let's do grounding attributions. Attributions. Low array. When a little dot down. Good or find. So quite tedious, but basically we're just trying to include as much metadata about the response as we can for the user. This way, if the user needs some of this information, it's there if it was generated. We're going to do basically the same logic. So grounding attributions, grounding attributions, grounding attributions, grounding attributions again. So we have citation metadata and grounding metadata. Candidate citation. Citation sources. Need only citation sources. Need only array. So definitely a little repetitive, but at least we're getting this information to the user. I don't know why my LSP is so slow right now. Candidate.plantation. Plantation sources. Okay. So we have grounding data. Let's do grounding metadata. Something. Grounding metadata dot. Grounding chunks. Search. Entry point. Hmm. Okay, this one's going to be a tiny bit trickier, I think. Oh, it's okay. It's the last one we need to deal with anyways, for now. Let's do it like this. Mm. Does grounding metadata only get generated once? Grounding. Mhm. Maybe what we do instead is we just do this. And then here, this is going to be a read-only array of grounding metadata. And I think that's pretty good for metadata for now. Oops. Citation sources is incompatible with index signature. Do I cast this to any in Bedrock? No, I do this. I forgot. Minor metadata is key, is just an object. Internal utilities. So key. What is metadata? Okay. With that, we should be able to stream a request. Well, let's go back to our Sketchpad. And instead of streaming requests, let's just stream. Now we're going to get back AI responses, which means we can do process standard out write response.text. And we need to wrap this fact send. Cool. It is working. It's alive. And if we also wanted to get the full response, we could do what we were doing before. And we could see the first thing that comes out is the metadata, where we get the response ID, the model, the metadata part, and we also get a first piece of text. And this is why I think streaming the parts is going to make more sense, because we really don't need the AI response container it does make certain things like nice, like you can extract the text a little bit easier, but I really don't. I think it makes more sense to stream the parts. Mattia, it's alive. Yes, it is. Very exciting. And then we can see here that the last part that comes out is the finished part. We've got no relevant metadata. The reason was stop reason, and we generated these tokens. Cool. Very cool. So now that the client is in a good spot, we're going to probably like stop here for today, but because the client's in a good spot now, we've got streaming working, we've got AI responses coming out and everything like that. The next logical thing to do would be to start fleshing out the language model. So at the moment, the only thing we've got in here is the provider metadata, but like when we use this in a program, like this is not how we want to interact with the client. We want to use all the nice stuff that comes along with the base AI package, like using the language model and injecting it as a dependency, etc. So probably the next time, maybe tomorrow, we'll start fleshing out the language model itself. And yeah, that'll be pretty good because once we have the language model fleshed out, that gives us like basically everything we need to use Gemini from like in concert with the Effect AI SDK. Cool. I'm very satisfied. Peace, guys.